Okay, so elimination, again, the steps are you identify what you're going to eliminate, and this problem is fairly easy to see that my x's are going to eliminate. So x's are eliminated. I'm left with 1y equals 2, so y equals 2. Once you find your first variable, you're going to take it and plug it into either one of the original equations. It doesn't matter which one you plug it into, it's totally up to you. So we have 2x minus 3 times 2 equals negative 2. Gives me 2x minus 6, which equals negative 2. I'm going to add 6 to both sides. Gives me 2x equals 4. I'm going to divide by 2, so x equals 2. So when you have your solution for a system is written as an ordered pair. So my solution is 2, 2. And that's a basic level elimination because it naturally eliminates itself. Okay, another one here. Oh, I didn't classify it. So because I have a solution that makes it a consistent system and independent. Here, again, it's pretty straightforward. Cancels. Oh no, everything cancels. So I end up with 0 equals 0. When you end up with 0 equals 0, this is a consistent but dependent system. So your solution is infinite solutions. Okay, so 0 equals 0, consistent and independent. Consistent and dependent. Infinite solutions. Next, here, oh look, 0 equals 4. Well, that's not true. That's not a true statement. So that means that this is an inconsistent system and there is no solution. Okay, so it's inconsistent and no solution. What that means that these are two parallel lines. Okay. So solve by using elimination. This one, nothing is easily eliminated. So I'm going to have to do some manipulation for myself in order for me to be able to eliminate. So you decide which variable you want to eliminate. I'm just going to go with x because it's on the end. And when you're eliminating, remember one number has to be positive and one has to be negative. My teacher always just taught us to make the second equation negative. You don't have to. But the first thing you're going to ask yourself is what is the LCM, I'm sorry, of 2 and 3? And the LCM of 2 and 3 is 6. Okay? So your goal here is to transform the coefficients for the x's into 6's. So what I need to do to transfer row 1, make column equation 1, I'm going to have to multiply by 3. And what I do to one side, I have to do to the other. To transform equation 2, I'm going to multiply by 2, but I need it to be negative, so I'm actually going to multiply by negative 2. And what I do to one side, I'm going to do to the other. So now I'm working with 6x minus 9x equals 0, and negative 6x plus 4y equals 10. So this is my new system, my transformed system. So from here, I can then eliminate, combine, that's a y by the way, combine like terms. So I have negative 9y plus 5y, plus 4y is negative 5y equals 10. Divide by negative 5, and I get y equals negative 2. Once I find that value, I can take that value and plug into either one of the originals. So going back to the originals, I'm going to use 2x minus 3y equals 0. And I know that y equals negative 2. So I end up with 2x plus 6 equals 0. I'm going to subtract 6. So I get 2x equals negative 6. Divide by 2. And I get x equals negative 3. So I have my x, my y, so my solution is -3, -2. And whenever you're not sure, you would take the values and plug them in. So if I'm not sure, then I can test it out. Well, -3 times 2 is -6. -2 times -3 is +6. And -6 plus 6 is 0. Checks out. -3 times 3 is -9. Minus -2 times -2 is +4. So -9 plus 4 equals -5. All double checks out. Means that I did it correct. Okay, let's try another one. So this one, if you notice, we're going to do y's because they already have the negative and positive, and I don't have to worry about changing the sign. So if I want to eliminate my y's, I'm starting off with, I'm going to ask myself, what is the least common multiple of 5 and 7? And the least common multiple is 35. So how can I transform 5 and 7 into 35? Well, they're both going to have to be multiplied by each other. So I'm going to multiply the first one by 7, and what I do to one side, I do to the other. And I'm going to multiply the second equation by 5. What I do to one side, I do to the other. And now I'm working with 21x minus 35y equals 77. And then I have 20x plus 35y equals 5. Combine my like terms, gives me 41x equals 82. Divide by 41, and I get x equals 2. So now I take what I got, and I'm going to plug it into one of the originals. It doesn't matter which original. So I'm going to do the first one. So I'm going to use 3x minus 5y equals 11. So that gives me 3 times 2 minus 5y equals 11. So 6 minus 5y equals 11. Subtract 6, and I get negative 5y equals 5. So therefore, y equals -1. Okay, I can check myself if I'm not confident, plug both values in. So 2 goes in, 6. 6 plus 5 is 11, checks out. 2 goes in, that's 8, -1. 8 minus 7 is 1, all checks out. So my solution is 2, -1. This should look very, very familiar. Should not be your first time seeing this. All right, in terms of a word problem. So linear systems occur in design of roof trusses for homes and buildings. One of the simplest types of roof trusses is an equilateral triangle. So we have here 300 pounds at the top, work W1, W2, 45, 45. And so if it's equilateral, I guess it goes all the way down. That's part that's equilateral, and then they bring it up. So what's that thing called, that class called? Geometry. So in geometry, you learned about equilateral triangles and how that means that they're equal sides. The equal sides come from here. So the outside, W2, W1, and then this base would be make an equilateral. What they did is they put this floor in, I guess, the floor, the base. And so it's not, now you have a isosceles instead of an equilateral that you're looking at as the roof. Okay, here it says if the truss in the figure has two 45-degree angles, and if the weight of the truss is 300 pounds, then the weight on each rafter is given by the system. So here's our system. Weight 1 minus weight 2 equals 0 times 1 over square root of 2, weight 1 plus weight 2 equals 300. Find the weight on each rafter symbolically, graphically, and numerically. So it wants us to do it by hand, verify by graph, then verify by table. So by hand, first thing we're going to do is make sure it's in standard form. So this would become 1 square root of 2 W1 plus 1 square root of 2 W2 equals 300. Okay, so that would be written in standard form, what they would look like. Now, I think I went straight to graphically. So for purpose of graphically, we're going to let this be x, this be y, this be x, this be y. And so in order to do it graphically, we're going to need to be able to put it in the calculator, which means that we have to get our y by itself. Which way I did this? Yes, which? Okay, anyways. So this would be standard form if we're going to do it by hand, but I don't think we did it I didn't do it by hand. Yeah. So I went ahead and and rewrote them. Can't remember. Yeah, I did it right. Okay. So here, I didn't leave myself any room. So we have x minus y equals 0, which would become y equals x. That's my y1. And then in the next one, we have 1 over the square root of 2 times x plus y equals 300. And in the calculator, this is going to become y2 equals 300 divided by 300 times, not divided by. (300) times the square root of 2 minus x. Or you can write negative x, whatever. But this is what we're putting in the calculator to find our value. So we put in y1, put in y2, and then graphically, we go look at the table. I mean, numerically, we go look at the table, and we're looking for when are they close or have the same value. And that'll be a long way to scroll, so I did it for you already. It would take us all the way to 212 to see that they have a value that's close, okay? But calculator-wise, you would just graph it and do your zoom out, zoom in, and find the intersection of the two. But on table, which we hadn't looked at, it would take us some scrolling to get all the way to the point where the values are the same, which is close enough here. So approximately, x would equal approximately 212. So pertaining to this problem, x is weight 1. So weight 1 would equal approximately 212. And that's that. All right, next real world example, volume. So the volume V of a cylindrical container with a radius R and a height H is computed by V R comma H equals pi R squared times H. The lateral surface area S in the container, excluding the circular top and bottom, is computed by 2 pi R H. So here are your two formulas for a cylinder. For a cylinder, which we are all very familiar with. So what we're going to do with this, it wants us to write a system of equations whose solution is the dimensions of a cylinder with a volume of 40 pi cubic inches and a lateral surface area of 60 pi square inches. Okay, so your lateral, remember that's just the face, not including the base. So you just want the 2 pi R H, and you're not worried about the pi R squared, which is the top side. Okay, and then we're going to solve symbolically. So first thing we write is our system. Pi R squared H equals 40, and our lateral equals 2 pi R H equals 60. So here's our system. Okay, then from there, we are going to solve each equation for H. So pi R squared H equals 40 pi. That means H equals 40 over R squared. For 2 pi RH equals 60 pi. That leaves us to h equals 60 pi over 2 pi r, which is 30 over r. Now we're going to make them equal to each other because we're saying h equals h, and then we're going to solve for r. So we're going to have 40 over r squared equals 30 over r. To solve, we cross multiply. 40 times r is 40r. 30 times r squared. When it comes down to it, we're going to end up with 40 equals 30r. And so therefore r equals 4/3. So we now know that r equals 4/3. We're going to take the value of r and substitute it into either one of these equations to solve for h. We're going to do it in 30 over r because that's the easier one to go into. So we have h equals 30 divided by 4/3, which means you keep, change, and flippity flip. And so that gives us 90 over 4, which equals 45 halves. So our values are, the radius is 4/3 inches and the height is 45 half inches. And that concludes that problem. You can verify it in the calculator by graphing what you solved h for both of them, but instead of using r in the calculator, you would use x, and then you graph, find their intersection, and you're going to get 1 and 3, 3, 3, 3, 3, 3, 3, and 22 and a half. Okay. And so we did it right by hand. All right, this one, solving the system. So the difference from Algebra 2 to here is that our system can be made up of anything. In Algebra 2, you just focused on linear systems and your 3 variable system. So what we're going to do here is solve each for y. So we solve each for y, and one's going to be our y1, and one's going to be our y2. And we're going to take these and plug them into the calculator and find their intersection. So the solution is approximately 1 in 42 thousandths and 957 thousandths. All right. The strength of a rectangular beam varies jointly as its width and square of its thickness. If a beam is 5.5 inches wide and 2.5 inches thick, supports 600 pounds, how much can a similar beam that is 4 inches wide and 1.5 inches thick support? So we're going to first identify our variables. We have S equals the strength, W equals the width, and T equals the thickness. So we have strength, width, and thickness. Hopefully you all agree. Okay, so we're going to set it up. So that leaves us with S equals K times W times T squared. And that comes from the first sentence. The strength of a rectangular beam varies jointly as its weight, as its width, and square of its thickness. Okay, because we're varying jointly, that means that there is a variable K, our constant, that we have to find. So we're going to find K. So we're going to use the values that they gave us, which was here where it said if a beam is 5.5 inches and the width is 2.5 inches, then it supports 600. So we're going to use those values to solve for K. Plug them in, solve for K. So this is the exact value of K. So now we're going to let W equals 4 and T equals 1.5, and we're going to solve for S. So using the exact value of K, because if you don't use the exact value when you're doing your homework, it will know and your answer may not come out how it's supposed to. So my exact value of K, plug in my width, plug in my thickness, and I get approximately 157. So the beam can support about 157 pounds. Go backwards. So again, taking this problem, it was a joint variation, okay? That lets me know that I have S equals, jointly means I'm multiplying. So varying jointly, I'm multiplying these three, and K is my constant. All variations are going to have a K, and you have to solve for k. And they give us enough information to solve for k. So they give us our 5.5 inches width, our 2.5 inches thick, and our 600 pounds. So they give us 3 variables to solve for that one unknown variable. And once we have that one unknown variable, we can then set up our equation to solve for the rest, which is exactly what we did. All right, so that concludes